Hi guys, so what are we going to do in this lecture? We are going to do a generalized Pareto distribution. Okay, how do you define a generalized Pareto distribution? This is just GPD, okay, and alpha, lambda, and k. Okay, these are the three parameters which are going to use. The PDF is written right here, okay. This is a generalized Pareto distribution. What are we going to do in this lecture? This lecture we are going to do expectation of x. Okay, if you see expectation of x, I have written this. Okay, it is for a two parameter case. If you see, this is similar to what you have done in last lecture. Okay, so what new are we going to learn? We are going to learn expectation of x using a new method. Okay, then with respect to expectation of x square, I will give you this as an homework. Okay, you can solve in a similar lines with expectation of x. Okay, in order for your convenience, okay, I will just upload a photo of the proof, okay, so that you could check, or you could just check the final answer, whatever you want to do, that's absolutely fine. I will upload a photo, hmm, and then we are going to use a generalized Pareto form of expectation of x using this PDF. Okay, these are the three things which are going to do. Okay, let's start with expectation of x. So while starting with expectation of x, I've just wrote it x into f of x dx. If you see, this f of x is for a two parameter case which is written in your tables book. Okay. Last time how did we do? We put t equal to this value and manipulated it, right? Now, okay. Now we are going to compare your this answer, okay, this answer with respect to a generalized Pareto distribution. We'll try to bring in that form, okay, and then solve. Okay, so I'm just writing down what step you need to perform. The step you must compare pair. This is your expectation of x, that is full formula with respect to the generalized Pareto distribution. This is the basic aim which we are going to perform over this expectation of x. Okay, so let me just copy paste this. Okay, for your convenience in order to view it. Okay, I'm just keeping it right in the middle. Okay, so right in the middle, so you could have a look whenever you want while we are manipulating it. Okay, so let's start with it. If you see now, right now, just forget this thing. Forget it. Okay, this does not exist as of the moment. We are just focusing on the this part. Okay, so if you see, we do not require an alpha term. We do not require an alpha term, so this alpha term I can just take it out. Even we require lambda raised to alpha, so we'll keep this and this as well. Okay, so I'm left with alpha integration from 0 to infinity lambda raised to alpha into x upon lambda plus x raised to alpha plus 1. Can I write this as 2 minus 1? Yes, now it's mean one and the same, right? So while comparing these two equations now, okay, I can state that my alpha here is alpha. Okay, I'm just stating all the parameters. Lambda is lambda and k is 2. Okay, so now in order to bring this in this form, okay, I have to manipulate this. Okay, it would be alpha integration from 0 to infinity. Lambda raised to alpha, x raised to 2 minus 1. So I want lambda plus x. Okay, I want alpha plus k. If you see, k is 1, but here my k is 2. Now what I will do? So in order for that, I will manipulate my lambda. Okay, I will now manipulate my lambda. I will write alpha minus 1 and I will take lambda out. It means one and the same now. Now I can write this as alpha minus 1. Again, now I can write this as alpha minus 1 plus 2. Now if you compare these two, Okay, it becomes alpha is equal to alpha minus 1. Okay, lambda is equal to lambda and k is equal to 2. Okay, so if you see this does not exist for the denominator case, therefore we came up to this conclusion. Okay, we manipulated our answer. Now we want this term, right? We know what is alpha. In this case, it's alpha minus 1, k is 2. We want these terms, so I will just write it in this format. Okay, it would be alpha upon lambda integration from 0 to infinity. Let me keep a bit space. Why? I will just tell you. Okay, it would be lambda alpha minus 1 x raised to 2 minus 1 upon lambda plus x the whole raised to alpha minus 1 plus 2. This would be alpha minus 1 plus 2. Okay, in order to form this, it would be alpha minus 1 and 2, right? So in order to equate these two equations, I have to multiply by its reciprocal. So I will multiply by alpha minus 2. Okay, alpha minus 1, sorry. Okay, upon 2 divided by alpha minus 1 plus 2. This way, if you see effectively, you could cancel out this whole number and you would be left with the previous part. So, which proves that you have done whatever you needed to do. Now, if you compare only this part, okay, which I'm highlighting, this does not indicate your GPD, Generalized Pareto Distribution. This indicates your Generalized Pareto Distribution, okay, with alpha minus 1, lambda, and k equal to 2, right? And sum of this is nothing but the PDF, right? So sum of PDF for all the values is nothing but 1. So I'm left with this. Now, in order to simplify, gamma of n is nothing but n minus 1 factorial, which is nothing but n minus 1 into n minus 2 and so on. Okay, so simple. So let's just manipulate it. Okay, I can write this as alpha lambda. Gamma of 2 is nothing but 1 factorial, right? This would be nothing but, wait, just a second. I'm writing this in a bracket here. Okay, this would be 1 factorial multiplied by alpha minus 1 would be alpha minus 2 factorial. This would be alpha factorial, right? Now I can simplify this as 1 factorial is 1, so I'm just forgetting it. So alpha minus 2 factorial upon alpha into alpha minus 1 into alpha minus 2 factorial. Yes, is just written as 8 factorial is equal to 8 into 7 into 6 factorial. Okay, nothing else. Now we can simplify it. Alpha minus 2 factorial gets cancelled, alpha gets cancelled, and left with lambda upon alpha minus 1. If you see, this is exactly the same answer as the previous case, right? So this is the second way. The only difference in expectation of x square is square, and wherever there is k, you will require 2. So I will just give you a final hint. Your answer this should come as nothing but alpha minus 2, lambda, and k is equal to 3. If it comes this, then you are absolutely right. Then it's just calculation. You just need to manipulate that for expectation of x square. Okay. However, I'll post a photo. You do not have to worry. You could just see it. It's quite easy. And now I expect you all to solve this. Okay. So moving on for a generalized Pareto distribution case. Okay. Let us start that. Okay. So let's do it for an expectation of x. Okay. It would be x into f of x dx. So f of x is this. So let me just copy paste it. This copy. Yeah. and here I will just paste it. Okay, f of x is this. Now let me write it in a proper form. It would be x into gamma of alpha plus k upon gamma of alpha gamma of k into lambda raised to alpha into x raised to k minus 1 upon lambda plus x raised to alpha plus k dx. Last time what did we do? We ignored this. So right now also I'm doing the same thing. Okay guys, I will just kick this out. It's too annoying. So gamma of alpha plus k upon gamma of alpha gamma of k integration of from 0 to infinity. Okay, integration of x into lambda raised to alpha into x raised to k minus 1 upon lambda plus x, okay, the whole raised to alpha plus k. Now x into xk minus 1 nothing but becomes x raised to k, right? So now I will compare this form with my generalized Pareto distributions form, okay, this form, okay, and then I will similarly form my result answer. Okay, let me just make this red so that it's a different color. Now if you see, I want this in the form of k minus 1. So I'll just write k plus 1 minus 1. Okay, where we can say that lambda is equal to lambda, alpha is equal to alpha, k is equal to k plus 1. Okay, the same thing. Now the denominator part. So let me just copy paste this. Okay, now I want this in this form. Okay, alpha plus k. So this would be alpha plus k plus 1. So there is this minus 1 term remaining, right? To make it sure, so I'll write alpha minus 1. Okay, manipulation. Alpha minus 1 plus k plus 1. I'll write this alpha minus 1 and take one lambda out in order to equate it. Okay, so now I got this term. Now I want this term. So I'll write it in a form. So what is our form here? Here the form is nothing but your alpha. Your alpha is alpha minus 1. Your k is k plus 1, sorry. And your lambda is lambda. Okay. So in this form I'll write it. It would be nothing but gamma of alpha plus k upon gamma of alpha gamma of k multiplied by lambda integration from 0 to infinity lambda raised to alpha minus 1 into x raised to k plus 1 minus 1 upon lambda plus x raised to alpha minus 1 plus k plus 1. Okay, so this would be nothing but alpha. What is alpha here? Is alpha minus 1. What is k? It's k plus 1. Okay, divided by gamma of alpha minus 1 into gamma of k plus 1. In order to make it as a previous situation, I just have to multiply by its reciprocal. Okay, so I'm just multiplying by the reciprocal of it. Okay, I'll just take this term out. Everything else remains as it is. Okay, so let me just copy paste this. Control C, Control V. You have to write down, guys. तुम लोग मेरे जैसा छाप मत मारना क्योंकि for your thing it's really important for you all to write in your notebook. हाँ, मैं आलसी हूँ, मैं कर पाऊंगा, तुम लोग नहीं कर पाओगे ये. Okay, I'm just rubbing this out. Okay, I'm shifting this towards my right. Okay, again I will select this. So I'll just move it right here. Okay, now going ahead with it. Okay, so let's simplify. This would be nothing but this minus 1, this plus 1 goes away. Okay, so I'm directly able to cancel this. I'm left with alpha minus 2 factorial into k factorial upon alpha minus 1 factorial into k minus 1 factorial. Okay, multiplied by lambda. This would be a generalized Pareto distribution. Okay, let me just highlight it. Okay, so this will be your generalized Pareto distribution with parameter alpha minus 1, lambda, and k plus 1. This is nothing but a PDF. Sum of PDF of all values is always equal to 1. Similarly, as sum of probability is equal to 1, okay, for all the values. So, I'm left with alpha minus 2 factorial into k factorial upon alpha minus 1 into alpha minus 2 factorial into k minus 1 factorial. K minus 1 factorial, which would turn out to be this cancelled, okay, multiplied by k minus 1 factorial, no? So I have to simplify here, sorry. K minus 2, k minus 1 factorial means that I will simplify it here. Okay, so this and this gets cancelled, multiplied by lambda as it is, I'm left with k lambda upon alpha minus 1. With this, okay, I'm done with the generalized Pareto distribution. Make sure you do expectation of x squared. Okay, I will just upload a good photo. Okay, we meet for the last part of chapter 15 in the next lecture, where we'll be covering variable distribution as well as the Bohr distribution. Okay, till then, have a great day. Okay, bye bye.